Adaptations. Studying adaptations of specific animals. We know how some animals have adapted wonderfully to survive comfortably in the habitat that they are in. Let us look at the adaptations of some organisms in detail. A camel lives in a desert. What are the conditions there? The ground is covered with sand that becomes very hot in the day. There is extreme dryness, not many plants and hardly any water. There are frequent sandstorms in the desert. Now let's study the features of a camel. A camel has long, strong legs that helps to keep its body away from the hot sand. Camels' feet are wide, so they can walk on sand more easily. Their huge feet help them to walk on sand without sinking into it. What about the hump? There's where the camel stores fat. This stores fat is used by the body when food is scarce. The hump is firm and upright when the camel is fed well and in good condition. But if the hump becomes floppy, it means the camel is exhausted after a long journey. A healthy camel's body temperature fluctuates, that is, changes throughout the day. Do you know by how much? From 34 degrees Celsius to 41.7 degrees Celsius. This hardly happens in any other mammal. But this allows the camel to conserve water by not sweating as the environmental temperature rises. Camels are able to save water in their body since they excrete very little urine and their dung is dry too. A camel can go for a week or more without water. They can drink up to 46 liters of water in one drinking session. Look at this 1 liter water bottle and think how much water the camel drinks at one go. 46 of these. Camels have long eyelashes that protect them from the blowing sand. It has thick eyebrows that protects its eyes from the desert sun. They can even close their nostrils for short periods to avoid the blowing sand going up their nose. Camels' ears are covered with hair, even on the inside. The hair helps keep out sand or dust that might blow into the animal's ears. Camels have thick lips, so they can eat the prickly desert plants without feeling the pain of sharp thorns. The color of their bodies helps them to blend into the environment. Have you seen a cactus plant in the desert? It is covered with spines. The spines are modified leaves of cactus. They have taken this form to minimize the loss of water through transpiration. Transpiration is the water that the plant generally loses through the open pores in its leaves. This happens a lot during photosynthesis. The cactus stores water in its stem. The stems of cacti have tough skin covered with wax to prevent loss of water. The thorny leaves also protect the stem from being quickly eaten by other animals. Plants in the desert mostly store water in fleshy leaves, stems or roots, basically in places where it won't be easily lost. Such plants are also called succulents. The roots are shallow and spread out near the surface. This is so that they can quickly absorb any rain that falls and they can get it from a larger surface area. There is no use of deep roots in the desert. There is hardly any water underground. So the roots spread out longer rather than deeper. And there is one more extremely amazing adaptation in some desert plants. You have learned that plants perform photosynthesis in the daytime. When they do so, they use carbon dioxide in the air and they release oxygen and water vapor into the air. The pores on the leaves through which this exchange happens are called stomata. The carbon dioxide is normally taken in through the stomata and the water vapor is also lost through the stomata. What many succulents do is that they open their stomata at night when the temperature is not so hot and take in carbon dioxide and store it. In the day, they perform photosynthesis using this stored carbon dioxide. They do not open their stomata during the daytime at all. Again, they open their stomata at night. When the temperature is cooler, the water vapor loss is lower. In fact, they lose only 1/10 the water that they would otherwise lose by doing photosynthesis normally. Succulents can also lower their energy requirements when the water available reduces further. At such a time, they keep their stomata closed day and night, so the water loss nearly becomes zero. Now, let us look at how fish can survive in the water. All living organisms need to breathe and take in oxygen. How does a fish do it underwater? Fish take in water through their mouth and then force it out of their body through special openings called the gill slits. Gill slits have lots of blood vessels. As the water passes over them, they absorb the oxygen that has dissolved in the water. Did you know that while all fish have gills, some can also take oxygen from the air by gulping? 80% of the body of a fish is made up of muscle. In humans, only about 30% to 40% is made up of muscle. And a fish's muscles are packed along the sides of its body. That's where it gets its swimming power from. That's why when a fish wants to move forward, it begins a side-to-side wiggle of its body that starts at its head and moves backward along the body. We know that the fish has a streamlined body shape to help it cut through water easily. It also has fins to move about in the water. The fin on the back of the body, called the dorsal fin, helps to keep the fish upright and stable. The tail fin helps to change the direction of movement with ease and to balance the body. You may know these things. Here's something very interesting about fish that you probably didn't know. Most fish have swim bladders. That's like an air sac inside the body of the fish. It helps the fish stay at a certain level in the water without swimming. Fish that do not have a swim bladder have to keep swimming, otherwise they sink. Fish like sharks and rays do not have swim bladders. So most sharks have to keep swimming to stay at the same depth in the water. Here's another interesting thing about some sharks. The great white shark and whale shark in particular. These sharks need to keep swimming to force water into their mouth. Then the water can pass over the gills and then they can get oxygen into their body. So, if these sharks stopped swimming, they would die from lack of oxygen. What about the other fish then? Most fish can gulp in water. So, even if they are not swimming, they can pull water into their mouths. There are plants that live and grow in the water too. How are they different from land plants? One thing that is different from land plants is that they have no strength in their leaves and stem. On land, the stem has to support the plant and hold it upright. Water plants are supported by the water all around them. So, they have no support mechanism developed inside. If you bring them out on land, they just hang limply. The other thing that land plants have is a root system to absorb water from the ground and a circulatory system to send it all around the plant. In water, there is no need to have these systems, so they are absent. The whole plant can absorb water and there is no circulation system inside. The roots just hold the plant to the soil, that's all. That's why if you remove these plants from the water, they will wilt even if you place the stems in water. Normally in land plants, all the leaves of the same plant are similar. In water plants, the leaves that are underwater have a different structure from the leaves that float on the surface of the water. The underwater leaves are quite divided so that they don't get damaged in the water. There are air sacs in the stems of these underwater plants that help it float in the water. Acclimatization. Adjusting quickly to a change in the environment. Have you seen a mountaineer climbing at great heights? They have difficulty breathing and need to breathe faster as they climb. After some days, their body adjusts to the changed conditions on the high mountains. When you go to a higher altitude, the atmospheric oxygen reduces. You need to breathe faster to inhale enough amount of oxygen. That's why we struggle to breathe for some time. Once your body adjusts to changed conditions, you can breathe with ease. Basically, you become acclimatized to the surroundings after some time. The small adjustments made by the body to overcome small changes in the surroundings for a short period of time are called acclimatization. This is different from adaptation. Adaptation takes place over thousands of years. Adaptation happens gradually over hundreds or thousands of years. Acclimatization is much faster. It's usually a matter of a few hours or days. Also, acclimatization takes place for that particular individual. For example, if Sham is at Ladakh for a week, only his body gets acclimatized to lesser oxygen. The whole human race does not get adjusted to that change. When adaptation happens, it's for all animals of that species. Additionally, acclimatization is temporary. For example, Sham's body returns to its normal oxygen need when he comes back from Ladakh. If he goes there again he needs to be acclimatized to lesser oxygen. When adaptation happens, it's quite permanent. What did we just learn? Different living creatures adapt to their habitats in different ways. Adaptation takes place over thousands of years. Adaptation normally takes place for the whole species in that environment. The small adjustments by the body to overcome small changes in the surroundings for a short period of time are called acclimatization. Acclimatization normally happens for only the individuals of the species that are exposed to the change.